Hi, I'm Barbara Tharp, and today we're going to look at separating solutions. It's the 8th activity in the My World Teacher's Guide for Water. The objectives for the lesson are aligned to the National Science Education Standards, specifically to the standards related to science as inquiry and the life science. The objectives of this specific lesson are looking at basic, simple paper chromatography to investigate a mystery liquid. The concepts: many different substances can be dissolved in water at the same time. Now, what are we looking at? These are our materials that we're going to use today, including the beaker, cup, 3 different colors of food coloring, red, blue, and green, rulers, scissors, and coffee filters. Now, what we're going to do, first of all, is you want to mix the liquid. And the liquid, basically, you're looking at about 150 milliliters of water. And within that water, you're going to want to put 10 to 15 drops of red, green, and blue. And make sure that you do this, because it can be very messy. Once you have this, you want to give each group just a little of it. You can look at the cup and say, well, if it's about a centimeter high, that's about all the colored liquid that you need. You want to ask them, what do you see here? What does this look like? What colors can you see? Basically, they're not going to see much. They might see a greenish tinge. Say, well, how could we determine what's really in here? And to do that, what we're going to look at is basically chromatography. We're going to look at how can we find out. And to do that, we're going to take coffee filters, and we're going to look at how we can take that coffee filter, and I've already cut some strips. We're going to cut strips about 10 centimeters by 2 centimeters, and each student will get their own strip or strips, put their initials on one end so everybody knows whose strip is whose, and basically put that strip into the liquid. Very carefully. You want to try to get it in there so that it doesn't touch the edge of the cup if possible. You want to put just the very tip of it in there and let it go. Now, what you want them to do is watch that for a while. And as they watch that, and for 5 to 10 minutes at most, watch and see what happens, and they're going to predict what are they going to find in there. And I can see already that you have water. Colored water is creeping up, and that's capillary action. You could talk about capillary action, the way that water molecules will travel up through a material. So we prepared the strips, we put it in the mystery liquid. We're going to wait about 5 to 10 minutes, and then you're going to carefully take it out, and we're going to predict what, if we think these colors we don't tell them about these colors, but what colors could possibly be in that water. You take it out, and you want to dry it on a piece of paper. So we take it and we lay it out to dry. Now, again, what I've done is I've already prepared some ahead of time for you to see what it's going to look like. And what the students will see is that even though the water looked pretty black, what they're going to come up with is a whole series of colors. Normally the blue comes to the top, you've got the yellow in the middle, and the red at the bottom. And what's happening? Usually it forms bands like that because of the molecular structure of the water, the capillary action, and the different molecules have different weights, and so the red obviously is a heavier weight than the blue, and that's why you see them travel to different areas of the paper strip. So immediately you can see that what's happened is that they're looking at a color strip. This chromatography, it comes from Greek words for chromo and graphene, which means color writing. And it's a simple technique to separate out different substances and liquids. You can do this with grass and alcohol and come up with the different colors in the grasses, or there's a lot of different ways you can do this with different kinds of inks. But basically what you're seeing is that because of the polarity of water, the way it will climb up in the capillary action, that what happens, how it literally carries the color up the piece of paper. Okay? There's an extension for this activity, which is kind of a cool way to just have fun with the class and let them again look at chromatography in a different way, and that's why making snowflakes. And there's information on how to make the snowflakes, how to fold them, how to dip them, and they're kind of a neat thing to do it, for instance, at Christmas time and hang on the windows if you're lucky enough to have windows in your classroom. So these all have to do with chromatography, but also looking at what things can possibly be in a substance and how they might break down if they were to be filtered out. I hope you enjoyed this. Thank you.